This is a recording of Karl B. Hodges of 19169 Harbor Tree Court in Lake Fairways in North Fort Myers, Florida, 33903. Karl's phone number was 813-731-1189. The recording was made on January 21st, 1989 by Jim Walkinshaw of the Oldsmobile History Center. This is tape number 1 of 2 tapes. Okay, Karl, if you would just start us with your name and your address and your phone number, please.
Well, this is Karl B. Hodges, and I live at 19169 Harbor Tree Court, North Fort Myers, Florida. And the zip is 33903. The telephone number is 731-1189 with a zip of 813.
Okay.
I guess that covers that.
That's that. Now, when did you start working at Oldsmobile, Karl?
Well, the date on this card says 8/17/42.
1942.
And I was 27 years old, and I only weighed 135 pounds. Of course, the hair is not brown anymore. The eyes are still brown, but the hair has turned gray.
Yeah, okay. Well, where did you hire in, Karl?
Product engineering.
Okay. To do what?
Well, that was working on the board at that time.
All right.
Drafting board.
Okay.
It was a little peculiar in so much that at that time I had worked for 8 months at the telephone company. And one day I came in, and the personnel office was right across the hall, and he leaned out the door, and I had filled out an application. He said, "There's an application for somebody over in plant or product engineering," I think it was. And so I unlocked the door, put my tools in, went over, and that started it.
I'll be darned. Okay. What? And you went to work on the board, Karl?
Right.
Okay. Doing what kinds of
well,
things were you doing?
At that time, they were building 2 kinds of shells, armor piercing and the other kind.
Okay.
These were 75 millimeters.
All right.
They built 75 millimeter cannons for tanks. Those cannons had a recoil mechanism on the end of the barrel, plus all the breech mechanism.
All right.
And they built 20 millimeter guns, which had a feeder mechanism. And at that time, there was out the old engineering building. In back was a big parking lot, and they had 2 test positions there, and they must have been about 200 feet apart. And there was a tower came up, and then there was a tunnel underneath. And the guns were mounted in one side, and they were shot down this tunnel into a tube filled with sand with a plywood end on it.
Okay.
And there were big doors to be closed so that when they fired automatically, if the gun should blow up or something happened, somebody wouldn't get hurt.
So there wasn't a guy standing right there next to each gun?
No, only if it was maybe one shot, they might leave the doors open. But if it were a progression and they wanted to see how the feeder mechanism was working, why then they would close these big steel doors. And of course there was ventilation so that the smoke could get out.
Yeah.
And
it was a 2-gun position, sort of
there
thing?
were 2 places. You could mount a gun here and a gun here.
All right.
And so probably if they were tearing one down here, they could operate on this one.
Did they shoot every gun?
No, this is mainly for engineering test.
Okay, so it was a test.
Like your feeder mechanisms, they want to be sure that it was an interlocking link, and that they wouldn't jam, and where it would throw them, you know, what the trajectory was when they came out of the gun.
Yeah.
And so consequently, they fired quite a few rounds just testing some of this equipment. And it, well, I don't know how long we worked on feeder mechanisms.
Were the product folks were actually doing the design work on the guns, Karl? during the war?
As far as I know, they were. Now, those things get rather complicated sometimes.
Yes.
Some information comes from here, and so you say, well, that sounds good, let's test it. And who knows where all of it came from. That I don't know too well.
All right.
We built boxes to house the barrels for the 20 millimeters, all different kinds. They would ship them these were wooden boxes with dividers and everything to hold it in position. I remember drawing all kinds of boxes to ship those things in.
Now, was that just a regular shipping box for every unit, or was that just specifically for the product test?
Just for the I think they built the 20 millimeter barrels there. I'm not
Yes,
certain
they did.
how much what they did and
Yeah,
how much they did.
They built.
But these boxes were to ship them in. They didn't just send them loose in a
Right.
gondola or something. Each one was boxed, or not each one, each several were boxed. So maybe 2 or 3 layers, and they all went in a certain way in the box.
And so you got to draw that out.
Well, that was, I suppose everybody worked on those darn boxes. It was, there were certain restrictions as to how they were made, you know. And of course you had all the insignia of ordnance, which was a bomb with a little flame up, and that was put on the drawings too. In fact, as I had probably still got it, a vellum thing with a lot of prick holes, and you could lay that down and gave you the centers in order to draw one of these so it would be authentic, not just something freehand. So that was that took us through the guns. I can't remember anything spectacular about the test work. I know they didn't test 75 millimeters.
Pretty good sized gun,
Oh yeah.
Yeah. Where was your office at that time, or where was the drafting room?
This building that I told you I thought was known as the Olds Motor Works. That's what it had in the stone up above it. Well, it's right across the street from the new engineering building.
So that's building 64.
Yes.
Okay.
Yes.
Old building 64.
That's the second floor.
You were on the second floor of that building. Okay.
And, downstairs was experimental build-up and this sort of thing. I don't know exactly what they used it for during the war, but some of it was that sort of thing. And then, of course, on the third floor was an auditorium.
Okay, sure.
And the personnel department, sales, I think it was, had something to do with that auditorium, so that if they had a function, then they cut the air conditioner off. And if you think that didn't get hot, oh boy. And at that time, a lot of people smoked and that, and gee, the room would be just blue.
That old blue haze.
But the lights were a mixture of blue and yellow, but they had big transformers on them, and those things used to turn out an awful lot of heat. Finally, they took those out and put in all fluorescents.
Oh yeah.
And then at one time we did have a individual fluorescent light that we could move around, but the lighting wasn't the greatest and the air wasn't the greatest.
But somehow we got the work done.
Fact is, we used carbon tetrachloride at that time to clean drawings. Anything done for the government, of course, was inked.
Oh yes.
And they also had a thing that they called, there was a photograph of the piece, and because there were so many different finishes and requirements, they did what was known as zipatoning. And a zipatone is a transparent piece of film that's waxed, and it has different
the pattern.
Different pattern. And you'd lay that over, and you could cut around it to fit the particular part on this picture. So that, and then there'd be a key down below that this was a certain finish and that was a certain finish. I never worked on that, but a fellow by the name of Bill Holt did. In fact, he did most of that work for a long time. But you cut it, you just laid it on and took a knife and cut around it, and it would stick down, and then they could make prints of that, and it showed exactly what the finish was. Better than to have it
colored
or
which wouldn't print.
Well, at that time, you couldn't use color. Now, originally they made blueprints, which were blue background and white lines. And that was a wet process. Well, that's great, except that of course, you're never supposed to scale a engineering drawing.
Yeah.
But, boy, believe me, no way. So somewhere along the line, all that equipment disappeared, and they went to white prints, which
Oh,
were
yeah.
white background and blue lines.
Mm-hmm.
If you wanted to drive somebody crazy with a blueprint, use a red pencil.
Oh, yeah. Uh-huh. Right.
No, the yellow was the
Yeah,
prescribed
yeah,
thing if you
yeah.
marked up one
Uh-huh.
to use yellow.
Uh-huh.
And of course, they made sepia drawings for, they could reproduce those or run them through the
Yeah,
machine and
yes.
off of sepias. And those you could change with a bleach.
Mm-hmm.
You made your change
Mhm.
and then you could bleach out
Right.
all the other part. So,
See, how big was your desk at that time, your drawing table? Did you have one of these great huge ones?
oh yeah. I think I would say that they were 7 or 8 feet long, and
Mhm.
the drawings later on that I worked on all the frame stuff and that were, well, you use 54-inch vellum or,
Mhm.
or mylar
Mm-hmm.
with, and that plastic had a tooth to it. And it wear the skin off your elbows.
Yes.
But, no, those,
Okay.
the original boards weren't quite that big. It was only later. And,
Were
well,
those flat?
those were flat.
They didn't.
The big ones were flat.
They didn't tip up, so you could
No.
stand up at them.
Well, we did have some one time had a slight angle to them.
Uh-huh.
But when it gets that big, you just, well, some places had vertical boards.
Mm-hmm.
But every time you let loose of something, kaboom!
Yeah, it ends up on the floor. Right.
Well, there was a tray there, but
Yeah.
nevertheless,
Yeah.
you did have to hang on to things
Yeah.
pretty much. So they never did have vertical boards, but
Okay.
they did started out with some with a slight
Yeah.
angle, and they
Yeah.
had like sawhorses under them.
Yeah.
And then later on, when we went to the new engineering building, I guess even before we got in there, we had these much bigger boards.
Okay.
And they had drawers in the
Yeah.
sides and
Yeah.
so forth. But of course, when you start working on things like that, you don't use a machine or anything, you use triangles.
Yeah. Yeah.
And
Yeah.
the drawings are all on 5-inch grid.
Okay.
That's so that instead of taking a 6-foot line and say, well, it's back here,
Mm-hmm.
why you numbered the 5-inch lines, and the error
Okay.
was reduced to just any error you might make within 5 inches.
Uh-huh.
Now, part way along, I'm not certain just when, probably that was after we got into automotive work.
This is after the war, like after the war.
Yeah, after they started building
Mhm.
automotive stuff, why we switched from fractions to decimals.
Oh, really?
And
Prior to that, it had all been fractions.
All been
stuff.
fractions.
Mhm.
I think this
So-
ordnance work was
So,
all fractions.
okay, the ordnance work was in
Now, there may
fractions.
have been a few dimensions. If they
Mhm.
were very important,
Mhm.
it might have been something different. I don't just recall. But they went around and picked up all the scales.
Oh, yeah.
All the fractional scales. And they said, now, don't think in fractions anymore, think in decimals.
Okay.
And it's pretty soon it
Uh-huh.
gets so you do this.
How far, from a fraction standpoint, did they get down into the 64ths, or were they?
Yeah, 64th was
Was it-
about it, but you
was-
see, that'd be 0.15.
Right.
When you start going decimals, then you can get into
Yeah.
50 thousandths or what
Yeah,
have you. And
yeah.
so you had much better control. Whether their machining was better and their control
Mhm.
over the dimensions were
Mhm.
better, I don't know, but they wanted to be able to hold these dimensions
Mhm.
closer.
Mhm.
And fractions, it's almost
Yeah.
impossible
Yeah.
to do it that way.
What, after the war, Carl, what kinds of things did you end up being assigned to then?
Well, I started out in the engine group.
Okay.
And,
Who were you working with? I forgot to ask you, who was your boss initially?
well, in this ordnance work, there was a fellow by the name of Harold Nelson, I think.
All right.
And the whole room was open then.
Mm-hmm.
Then they divided, when automobile work came along, they divided up into engine, chassis, engine, transmission, chassis, and body.
All right.
But the chassis group had the biggest responsibility list. Oh
Mhm.
boy, they just covered, I could enumerate them, but
Mhm.
that doesn't mean much. Well, later on, that they changed over and spread out some of this responsibility into some of the other groups
Okay.
because we had such a big one. I finally ended up into the chassis. Well, starting out in the
Okay.
engine group, I think that was Gilbert Burrell
All right.
was on that, and at the time that they built the first jet engine,
Mm-hmm.
they kind of hand-picked who was going to work on it because they had to keep some back to work on the straight eights.
Yes.
And that engine, the people that worked on it, no drawing was checked. That's why they picked people that had been there long enough for something. And so it better be right. Nothing was checked, and fact is it's rather unusual in so much that most new engines go through a period of either 1 or 2 redesigns. The jet engine was put into production from the first go.
Really?
Right off, just what we did without any checking of drawings or anything. I remember when the first engine was started up, the sucker wouldn't start for some reason or other, and I happened to walk by the thing, and a bunch was standing around, and the cover was off the distributor cap. And I looked down, and I said, hey, no wonder it won't start. You know that little leaf spring that's up on the top? That was broken off. So they went and got a new rotor, put it in, and she took off just like a ruptured duck. The old straight eights had their problems because, like the exhaust manifolds, the engine grew so as it heated up. Trying to seal the exhaust manifolds against the block was a problem. I remember loosening mine and pulling them back, putting new ones in and putting it back on. And well, like all growing pains, I think they did some improvement on that straight eight, and I think they were up to about 7-to-1 compression ratio. And then when this jet engine was, or
the
this rocket engine was worked on, it was made, all the walls and everything in the block were heavier, with the idea that then they could machine a little more out and so forth, and they could raise the compression ratio from 7 to about 10. And so that same block saw a lot of service as it went up the line in compression and what have you.
Plus it was an overhead valve engine, which helped some.
I worked on so many things on that engine group that I just can't even begin to remember it.
Typical ones, Carl? Just a few?
All over. No, all over. Whatever came along the way. At that time, I think that was when I was in the transmission group. You had to do all of the. See, these things kept changing in responsibility, like all of your fuel and brake lines and all that sort of thing. Well, the piping on the engine was something that had to be taken care of in the engine group. But I'm trying to think what. I don't know. Just of course, once you start in on a new engine, and you got it running, then there's always improvements and this changes and that changes.
Little problems that need to be corrected and those kinds of things.
Well, you have to pull things out of the hat. For instance, you find that you can't get the transmission out unless you loosen the engine up, and if you loosen the engine up, you don't want to lose the position of it, so you make a slot in one place and a hole in the other, and you take this bolt out and you shove the engine a little bit, and that keeps its position, and then you can get the transmission out, and all of these things, and you do them all graphically to see how you're going to work this. In the same way with other things, you go up through a hole in the front crossbar and you lift the engine up in order to take the pan off. It's all those little things, just like on the Tornado when you got your torsion bars, you use a drift to pop the thing loose back where it's locked into the. The fact is that hole wasn't there until I talked to a fellow out in build-up, and he said, "Boy, it's that sucker getting that off." I said, "Can you do something about that?" So we put a hole in there and put a drift through and knock that
Give
loose.
it a clunk?
Yeah. But it's just a succession of things of that sort that go on. Transmission group, the only thing I remember about that too well was, I did some gear work, but all of the throttle linkage was done in the transmission group.
The transmission group really didn't design the transmission per se, did it?
No, they did a lot of experimental work on it.
All right.
But they didn't, as per se, they didn't.
All right.
But these linkages, your throttle and your shift linkages, and that were all done in the transmission group. And that is a pistol to run all that down through all the engine and miss everything. And you got bell crank after bell crank in order to operate it. What people never realized, and it always amused me, is somebody would say, "Geez, look, I got this new car, and boy, I just touched the accelerator, and I'm doing 50 miles an hour." what they don't realize is that you can design that linkage to throw that carburetor half open with the first
quarter inch.
Well, here's a circle. If you connect it here and you make a little motion angular, it makes a big difference this way. You get down into here and you go very far, and it doesn't
Not
do
much
very
happens.
much.
Yes.
Of course, then again, you might hear the remark, "Gosh, after 65, I don't have much left." But those things are all. It was I don't know. I remember. I think it was there, or when I got in chassis. Such things as your accelerator pedal and your linkage and your return springs, and all of that thing. I can't even remember. I think the load on that was around 6 pounds or something, because if you got too much on it, it tired the person's foot.
Felt like you're pushing on a battleship.
Yeah. But of course there was a little hoochie there when you could hook the spring here or here or here,
Get
and
more.
change the tension on it to suit what the situation was. If you happened to get a linkage that was a little tight, why maybe you had to increase it some. But all those things were important.
Sure.
You know.
And those would be typical kinds of tasks that people that were like you were working on.
Oh yeah. Well, usually your information came from a lot of sources. Sometimes he'd say, here's the problem. I remember about the last one I worked on was, how do you keep the rear wheels on a Tornado if you shear off the outer bearing from losing a wheel? And there is no room to work in around the brake or anything else. Well, I let that lay up probably for a month, and I worked on other things, and all of a sudden, I remembered a mark a fella had made that looked like the only place you'd ever be able to do anything was in the hub. And so I put a flange on the spindle and another flange in the hub. And then you knew how far it could move off before it came off the inner bearing. And then those bearings would drop down. They wanted something that would make so much racket, no way would you keep driving.
Okay.
And that did it.
Yeah, I bet it did,
What happened is that when you pulled it off, and it got out just so far, then the whole thing would settle down, would get in behind this flange. And then it would just growl and grind and squeal. And so that's the way you got some of your jobs was, look, we had a problem. And after just so much time, they might say, look, if you can't fix this, we'll get somebody else that can.
Now, in the early days, Karl, were we getting much what I call help from the government and those kinds of things, or weren't we getting that kind of help?
Only reverse help, you know.
Yeah, I'm being sarcastic. But in the early days, we didn't have that kind of thing, did we? In the 40s and the 50s.
Oh. Well, like failures is what you're thinking of, probably more than anything else.
No, I'm thinking in terms of the government says you got to do this or that, like emission stuff or safety stuff.
No, you didn't have to mention that. The safety things you did because it was bad publicity.
Yeah.
If the word got out that, everybody was losing a wheel or this or that, you were in trouble.
Yeah.
So.
Like that wheel thing you were talking about. That was we do that.
Actually, I don't know how many people had ever lost a wheel. Maybe a very few.
I suspect.
But they wanted to be sure that if the outer bearing was sheared off, you know, somebody had never greased the wheel bearing. So the heck with that. And if she seized up and would shear off, why then she started moving off the inner bearing. And when it did, you better have some way of stopping it.
Yeah, or it just goes zoom.
Yeah. So, there's just so many things that. You know, over 32 years, you work on an awful lot of things.
Yeah. Just it's nice just to capture the sense of how those things may have changed over the years, or the sense of the complexity of things, if that's a sort of thing that's talk aboutable. Well,
of course, your research work, a lot of the engineering work is to improve something. Now. It got to the point, of course, and well, somewhat that way anyway, that you design things idiot-proof, not just foolproof, but idiot-proof, because you had people, if they could do it wrong, they'd do it wrong. And so you did all kinds of tricks. If you had a pattern of holes, you'd move one off a 32nd or so, so no way could he get a bolt in there unless he had the thing in the right position. And such a thing as turning them 180 degrees and all
Okay.
this sort of thing, that you had to be so careful. Just the fact that they would show somebody how they're supposed to do it didn't necessarily mean that it would continue to be done that way.
Yeah.
So
Yeah.
on important things, why, yes, you had to kind of, you considered a lot of things in design anyway. You had ease of assembly, cost, durability. I don't know, just
Did you deal with the people out in the plant to any extent? The people that were putting the car together, so to speak?
once in a great while, you know.
Mm-hmm.
The main reason that you did was to make sure that you weren't boxing somebody into a miserable mess, you know.
Mm-hmm.
Just like I say, if you wanted to take a pan off and you had
Yeah.
to lift the engine, you didn't want them to try to hook something on and lift it, so you went
Yeah.
underneath and you had a pin come up through,
Sure.
and you provided the hole and
Place to push.
yeah, and you had to release the front motor mountings,
Mm-hmm.
and then you could push that up and you could get the pans off.
Yeah.
That's because there just was not enough room for
Sure.
the front crossbar.
Sure.
Well, then you got into such things as where, you remember there was a railroad track in Lansing, and when they'd go over it, they'd go shunk, and then they'd hook the front crossbar on the rail, and it just...
Yep. Tore it right out.
Yes.
Yes. I remember that.
Yeah.
F-85. That F-85
I
was
worked
that way.
on
Yeah.
that skid
Mhm.
in the front, to,
Mhm.
so that when they went down, they would slide, you know, it had
Yeah. Wooden hook.
a wooden hook.
Yeah.
And that was, well, you were always running into things of that
Mm-hmm.
nature.
Mm-hmm.
You had-
Those kinds of things would be found by drivers or engineers that were out testing cars or something.
Well, of course, in this case,
Well, that was found by real people.
Yeah.
Yeah. Right.
oh, sure, your proving grounds brought some of these things to light.
Mm-hmm.
And in some cases, it may be somebody said, geez, we ought to improve that some or do something.
Yeah, yeah.
So, you always got your eye on the dollar sign, and there's nothing wrong with that.
No.
As long as you're not talking cheapening.
Mhm.
If you're talking that you can do it some way that doesn't cost as much and is good or better, then fine.
Value.
Right. Then that's
Yeah.
what you are working toward. Well, let me see.
Now, you didn't stay doing transmissions and engines though forever.
No.
Okay.
After the rocket engine, there was a fellow in transmission wasn't getting along too well with his boss or something.
Well, by the way, who was your boss on the transmission side of the house?
Well, my immediate boss was Harold Howard, I think it was.
Okay.
And he since has died, of course.
Yeah.
In fact, as he married a gal that the rest of us knew from school.
Mm.
One of the nicest guys down there was Pete Estes.
Okay.
Of course, we knew him personally. He lived in East Lansing
Mhm.
at the time we did, and my wife knew Catherine, and our kids were about the same age and so forth.
See, he started in that, was it the chassis group that he started in?
Oh, he was
Was in
some
body.
kind of an engineer,
Yeah.
but Pete was a swell
Yeah.
guy. Gee,
Eventually ended up, I know, in the
just-
body end of the business. And
Yeah, of course he ended up at
and
the
then
top.
ended up at the top ultimately, yeah.
But no fellow would deserve it more.
Mhm.
There wasn't a mean bone in his body. He was just friendly and
Mhm.
very efficient and so forth. But gee, he was a swell guy.
Did you have any dealings with the chief engineers during those early years?
Not too
No?
much. No, they
Okay.
usually they worked through somebody else. You know.
Yeah.
Fact is, they took everybody's picture so that people higher up could recognize. You know, if they saw you kicking the Coke machine or something, they'd say, "That's the guy."
At least know who it is. Huh?
Well, something.
Yeah.
I don't know what was
Yeah,
done
no,
for that, but
I-
nevertheless, they did take pictures. Fact is, I ran across one here the other day. I don't know how far, whether it was just salaried help that they took these pictures or what it was. But,
This is your higher end picture, kinda, or something a little later on?
A special, they went around and took everybody's picture. Now, I think it was salaried help, I'm not sure.
Oh yeah. Uh-huh. Huh. I wonder what they did with all
I don't know, but they had a bunch of them.
those. Yeah. Isn't that interesting? It's a good picture.
That's what they took.
Uh-huh.
let's see, we go from transmission to chassis,
Okay.
and of course I told you chassis had a tremendous
Yes.
responsibility. Oh boy. Steering gears, wheels, brakes, exhaust systems, fuel tanks, fuel lines, radiators, well, and then of course you got into, that's another thing that came along, was the transmission cooler radiator.
Yeah.
That little one, like
Yeah.
for trailer hauling.
Yes.
Little,
Well, out front, yeah.
Yeah, I put that sucker in there and got pipes to it. But,
and of course, all the suspension system and all that stuff was
Oh,
part of, and the
that's all.
frame,
Yeah.
and the frame.
Well, I worked on an awful lot of stuff prior in the transmission group. Eventually, I did almost all the framework
Okay.
because that is a, oh, I told you, the drawing boards were about 8 foot long. Yeah,
Back
frame
on.
drawing could run 22 feet long or so because you had all these different views. And
Yeah.
what have you.
Yeah.
And of course, the way this was worked is that there was a front of dash.
Okay.
Anything to the rear of that was plus, anything to the front of that was minus.
Mm-hmm.
Then if you made a detail, you put one 5-inch line on it, and at a glance you'd say, well, that sucker's back here near the gas tank, see?
And all those lines were numbered.
Yeah, oh yes.
Yeah.
From the front of dash.
That's 0 point.
5, 10,
Yeah.
15, 20,
Yeah.
right down the line.
Okay.
And that's the way that you pegged. If you picked up a detail, you could
Mhm.
tell almost exactly what it
Mhm.
was on the car. Now, of course, the frame drawings were drawn on the left-hand side, and then anything on the right-hand side was shown on the left, because it's done this
Yeah,
way.
flipped over, yeah.
There was a time, you know, that we built a right-hand drive car.
Yes. Knew that.
Yeah, but...
Now that must have made a mess out of things. Linkages and
somewhat.
clutches and brakes.
Mainly, the engine's the same, but here's controls over here, you
Yeah.
know, this sort of thing. Yeah, I remember working on some things on right-hand drive. That didn't last too long.
No.
I don't recall just how long
I
that
think it
was.
was a holdover from the early days because that's where all cars were. to
Well,
start with.
I think that they maybe thought they were going to sell cars, more of them in Europe or
Mhm.
something too.
Mhm.
I don't really know, but
Yeah.
that kind of passed out the window,
Yeah.
just like your rag tops or your
Yeah.
convertibles.
Did you ever work on air ride?
Oh yes.
Okay, there's a good subject. What was going on there?
Well, I hate to say this, but most of us fellows in engineering, when we looked at it, said, boy, I don't know how this thing ever got down the pike. First place, it was a closed system.
Okay.
It had to be because of moisture and this and that.
Yeah.
It better have been termed a levelizer, because what really we were doing, if you had too much weight here, well, then it would bring the car up.
Mm-hmm. Mm-hmm.
And you had sensors so that, but so many people would come out in the morning and here would be one side
Yeah, it'd be
down,
lane,
this
yeah.
or that or something else. It was a terrible thing to control.
Uh-huh.
And you know that they finally had to call a lot of those cars in. They converted them back to standard because
Took the airbags out and put springs in them? And all
yeah,
that?
and took the
Yeah.
tanks out of them.
Yeah.
I wish I'd have gotten hold of one of those tanks. Those were nice.
Yeah, those were
pressure
good tanks, yeah.
I
Yeah.
could have found a use for one, but
Yeah.
I wasn't thinking.
So I wonder what precipitated that thing in the first place.
I think it was somebody's brainstorm, and somebody was afraid to say, where in the hell did you get that idea? You know, if it
yeah.
starts high enough, why,
Yeah.
you don't meet any resistance. But I don't know. God, that sucker was what, $700 for
Very expensive.
yeah,
yes,
for
in those
air
days.
ride against
Yeah.
a standard
Yeah.
ride, and what were you getting for it?
Yeah.
Just a levelizer.
Yeah.
It just really didn't make too good sense.
And we didn't sell very many of the darn things, so it
Well,
was
not
must
at
have been
that
a
amount.
must have been a
Well, it's the same
horrendous.
Same way with diesels, of course. The only thing that got those in was
Yeah, the
fuel.
the oil crunch.
Well, fuel differential.
Yeah.
But there again, you'd have to drive about 50,000 miles on any saving you made, and then you started saving a little money. Maybe. Well, by then the gas was
Back
back to
normal.
normal,
Yeah.
and here you are with this
Yeah.
thing, and they're noisy.
Yeah.
And of course, what you were paying for was extra sound deadener, 2 batteries.
Yeah.
Oh, here you go.
Everything.
Yeah.
It was heavy duty cranker and.
Yeah. It's just a lot of things that boosted the cost.
What was the air ride designed at Oldsmobile,
Yeah.
Carl? We actually did the design work for the thing. Was it used anyplace else other than Oldsmobile? Do you know?
Oh, I would think maybe Cadillac might have looked at it.
Okay. I think it only lasted. Was it a year or 2 at the most?
Yeah, 2 at the most, I would think.
Yeah. Okay.
Well, you had problems with leakage, and you were running around with a tester to find out if it was leaking.
Yeah.
And so
Yeah.
this was not a good system.
Yeah.
Well, part way along, then we come to the jet engine, and I was the only one worked on that for
This
a long time.
this is the real jet engine.
No, Buick had the prime
Okay.
contract.
All right.
And we had the contract through Buick for the rotor.
All right.
And that design came from England, I think it was. And there was no parts list, there was no assembly drawing, just a stack of stuff.
Here's all the parts.
Yeah,
huh?
here's everything.
Yeah.
And so I started through and wrote a parts list, and then I made an assembly drawing, and if you can find that, that was a beauty, because I especially made it because it was so big.
Yeah.
So that it could be reduced. And they finally reduced that down to a thing that would fit in your pocket.
A 3 by
You could
5 card.
read every one of those numbers.
Isn't that neat?
Because I made them a little larger, and I inked them.
Oh, yeah.
So when they photographed
Yeah.
it, there was no question about those
Dang.
numbers on those parts. But there must be something on that someplace.
I have not seen a print or a drawing like that.
Well, I know that I spent night after night. At the time we were supposed to build the blades.
Yes.
Well, the original design is a straight line projection. I won't get into that.
No,
But
it's okay.
nevertheless, all you had was a section here and one here.
Yeah.
Well, in order to get the contour of the blades, you needed a section here and a
Sure.
section here.
Sure.
I don't know how long I worked through those blades, 20 times size, developing these sections. The reason you go 20 times size is that you reduce your error by 20.
Sure.
If you got something and you're going to you don't want to make too many errors, then you bump it way up to lay it out, and then if you
Then
make a 20 thousandths error,
Yeah.
why
It
it's
doesn't-
minimal
yeah.
when you
Yeah.
reduce it back.
Yeah.
See? And but you had to lay all this stuff out and give them the angle of the blades and make all these new blade drawings.
And there were a jillion different blades, weren't there?
Not too much. I think there was 12 stages about of compression and maybe 4 or 5 of ignition.
All right.
And of course the compression stages were to build up the force of the
Yeah.
air through there.
Yeah.
But they were all indexed. Now that was one of the nice features. Prior to Olds working on this, they used to assemble the rotor, and each one had to be indexed. And they put it on one at a time because they were pressed on the shaft.
Okay.
And each one had to be indexed. Well, somebody got a good idea, and what they did was they built a mandrel that took all of these and had them all indexed. Then they put the shaft in a freezer, and they brought the shaft out, and they dropped everything went on. They took it apart, and
When it
warmed up, she was
It
right
was
on.
press fit.
Right. Every stage was all on at once.
Uh-huh.
That was a smart move.
Yeah.
But they finally machined these blades. They used belt grinders, and they backed them up with the shapes. That's what these
Yeah, the
sections were
sections
for,
that you were
so
making.
they could know where these were and to back them up.
Uh-huh.
And so they were able to turn out those blades. They were rather complicated. Christmas tree slots on the bottom of those in order to hang them in there. And the thing that always surprised me is that those were ball bearings on the
Really?
yeah, those were ball bearings from the shaft.
Huh.
And of course, you can make a thrust bearing for
Yeah.
even with a ball bearing.
Yeah.
But that's what they were. So, big suckers
Yeah,
like that.
yeah. That baby really turned though.
Yeah, I don't know. Well, if you see, you go out the airport, if the wind's blowing, well, here's the
Yeah,
thing going.
yeah,
That's how easy they
the
turn.
turbine is really rotating.
But
Yeah.
why? Whether there's less friction with a ball bearing or
Uh-huh,
something, there was
yeah.
some reason for it,
Yeah.
I'm sure.
Did they ever make one of those in product engineering as a test thing, or was that all done out in the shop?
As I recall, they had a pit, and when they made the shaft, they could suspend it in this pit and rotate it
Okay.
to make sure that something going to fly off. They wanted to know about it.
This
There
was
a
out in
weak
the
spot.
plant, wasn't
Yeah,
it?
out in the plant.
Yeah.
Somewhere.
Mhm.
I think they did speed them up.
Mhm.
They dropped them into a pit and
Spun them all.
Spun them. Yeah.
Mhm.
Well, this would show out of balance and
Yeah.
a lot of other
Yeah.
things. You know, maybe they were balancing them at
Mhm.
the time. I really don't know what they were doing.
Did they ever assemble one there in product over in your shops over there?
I don't think so,
Okay.
because it took special equipment
Yeah.
in order to press those stages on,
Yeah.
and get them indexed and everything.
Yeah.
I don't recall if they ever did anything like that.
How did we stay coordinated with Buick? If we were making the inside, they must have been making an equal number of things to go around the outside, weren't they?
That's right, but
Yeah.
there was drawings that came from England. Now, I'm not certain on this, but I believe that was all in the metric system.
Was it?
And I had to convert everything over to our system.
Oh my.
And then no parts list, no assembly drawings, and you just chewed your way through. You
Yeah.
had some general idea, you know, all the...
How many folks worked on that with you, Carl?
Well, I was the only one who worked on it for an awful long time.
Were you?
Then somebody did help me a little bit on those blades,
Mhm.
because it took quite a while to
I
lay
can
those
imagine
all
it
out.
would, yeah.
Oh boy, I
Yeah.
worked day and night on those
Yeah.
things. I'm trying to remember whether all the blades in the first 12 stages were alike, and there's contrast.
Mhm. Mhm.
I don't know. All I know is I made an awful lot of them, so there must have been a difference.
Yeah. 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 Wouldn't surprise me. They were all different.
It
Yeah.
could be in order to get
Just to
this
get the change
twist,
in
yeah,
pitch.
so
Yeah.
that you're
Uh-huh.
forcing that air
Yeah.
through.
Yeah. The shaft itself, did that taper? And
Yeah, there's a different diameter.
Mhm.
Like when you got up to the compression side, those
Yeah.
were big
Big disc.
babies, and
Uh-huh.
the shaft was bigger, and then
Yeah.
it narrowed down as it got
Uh-huh.
down
Yeah.
the line. You
Yeah.
had to do that in order. What forced it was that you wanted a ignition blade about so long anyway,
Yeah.
and so here's what's left. You know,
Mhm, mhm, yeah.
I've only got so much to get
Right,
to them in, and
right. Uh-huh.
you did have limitations, so that
Yeah.
indicated why it would be that way.
Yeah.
But
Do you know why we got the job, so to speak? How we got
probably
selected?
because we didn't get other prime contract.
Oh.
I don't know
Okay.
that was the case. All I know is Buick got the prime
Buick had
contract.
the original,
and,
yeah, uh-huh.
Then we subcontracted
Yeah.
the rotor.
Now that was done over at Plant 3. And I don't remember whether that plant was built then, or whether it was built for that. I think maybe it was built for that engine.
It could very well be, because there was a lot of special equipment in there.
Mm-hmm. Mm-hmm.
I was over there a couple of times. Oh, I don't know when.
Yeah.
You know, just at the
Yeah,
time.
just to
And I just wanted to see how they
yeah,
were doing
how it really
some
did
of these
it.
things. You
Uh-huh.
know.
Yeah.
And it was, we had some real fancy ideas, you know.
Yeah.
Like these dividers in between, before you got to the blades,
Yeah.
were rather thin. And they had to machine those, I guess, so that there again, metal was laid up against the back,
Mm-hmm.
and to support it, because you couldn't press them on here and do
Yeah.
something.
It just bent. Yeah.
So
Uh-huh.
you had supports in order to just machine those.
Mm-hmm. Was all that out of steel, or titanium, or was that something else?
I really don't remember the metal specs
Okay.
on the blades or
Mhm.
anything, no. There's a lot of reasons why you can use certain things.
Yeah.
You know, you
Well, it's
got-
high temperature.
Yeah,
and,
high temperature and
yeah,
corrosion,
yeah,
and you don't want them too ductile, and you don't want this, and you don't want that,
Yeah.
and then finally you end up with something you can use. Darn it. I'm just not certain what those
Yeah,
discs were. They
yeah.
could have been stainless steel, they could have
Yeah.
been aluminum.
Aluminum, yeah.
I'm not certain whether they got to where it was pretty hot or not.
You had never worked on a jet engine before, had
No.
you? First time you'd ever seen one, so to
Right,
speak?
right.
Uh-huh.
Here's a stack of prints.
Uh-huh.
Here.
Good luck, huh? How about that?
You know how it is, when
Yeah.
the going gets tough, everybody's gone.
Yeah, right. There you stand with the prince. Yeah.
And then when it's solved, look what we did.
Yeah. Uh-huh. Yeah.
Oh, yeah, well, it's,
Well, that must have been a unique experience, really, as you stand there and look back at it. In a
Yeah,
sense,
it's,
in that very few people really had that quote opportunity.
yeah, well, you can call it that.
Sure.
Well, we did work an awful lot of hours.
Yeah.
Because, in fact, is one year I worked every holiday except Christmas, and I was in for some hours on Christmas Day.
Long
And
year.
you're talking about a 40-hour week was unusual.
Mm-hmm.
And when it eased down, why, then you went in Saturday morning.
Mm-hmm. Mm-hmm.
And other than that, boy, it was... in fact, just during some of this war work, I remember one time we worked until 3 in the morning, and I didn't have a car, and the buses weren't running and everything else. My boss had to take me out to Ypsilanti because this had to go out the next
Sure.
day. And
Yeah.
we worked till 3 in the morning on that.
Yeah.
In fact, I can remember working 3 72-hour work weeks in a row. And I'm telling you, you're a walking zombie.
You've got to be.
Because
Yeah.
you're so concentrated,
Yeah.
and you've got to keep your wits about you, and you can't be daydreaming.
Yeah.
And
Take
I
a-
can remember 3 72-hour weeks in a row.
Yeah.
Boy, I don't ever want to do that again.
Yeah. Takes a lot out of a guy. But most of that was during the war kind of crunch?
No,
or was
I
that?
can't remember what instigated. Usually it was some crash thing.
Yeah.
I happened to miss the what was it, Livonia fire when the...
Yeah, the transmission plant fire.
I happened to be on
53.
vacation. Either they didn't know where I was or
Yeah.
something. I missed that one.
Yeah.
But that was that was another one.
That had to
Boy.
have been a big struggle with that,
Yeah,
trying to get
because
that
you had,
dynaflow in
well,
there.
you had to make new crossbars in the frame, and you
Yeah.
had to mount everything, and
Yeah.
then you're talking drive shafts and
Did it bolt
handles.
up? Did it bolt up right, even? It must have bolted on the engine different, even.
I don't know whether they had to make some different
Adapter plate or
adapter
some darn
plate
thing?
or something
Yeah.
on that.
We sold about, I think we sold 23,000 of those things like that. Is that
Mush away.
Yeah, right.
Mush away.
Yeah, yeah.
Yeah, ripe tomato acceleration.
Yeah, right.
Yeah.
Okay, so the jet engine and the chassis business, and then what? Where to?
Well, when I left from the chassis department.
Okay, so chassis was sort of home for
That
quite
was,
a period of
yeah,
time.
that was
Uh-huh.
the final. Once I got on all this framework, there really wasn't. You had to have somebody who was familiar.
Yeah.
For instance, I could tell you what any hole in that frame was for,
Uh-huh.
and it just. Well, I remember the first Tornado was a pistol too.
Yeah, that stub frame thing.
Yeah.
Yeah.
But that some of the design work on the first Tornado was done in the advanced design group. But the trouble is where they wanted to lock in the torsion bars. Do they
Mhm.
still build a Tornado with torsion bars or not?
No, wait a minute. No, it's not.
I wouldn't be
No,
surprised.
it's gone, yeah.
But back here, what happened is that they tried to build a crossbar to support this, but gee, they had to wrap it around. They didn't want this thing to get out of there.
Mm-hmm.
When they did, you can't do things like that,
Yeah.
not when they're highly stressed.
Yeah.
Boy, that thing was nothing. So my job was to do something about this. Well, the first thing I ask is, does this torsion bar always crowd upward? Well, yeah, that's the way it works.
Mhm.
I said, well, why don't we just put a couple of dimples in here,
Mhm.
and then I can get some depth to this crossbar.
Yeah.
Put a couple of dimples in, and it held the thing. You didn't have to wrap all the way around
Yeah,
it,
yeah.
because it was always forced up. It could never get out of there.
Uh-huh.
So those dimples were only about that deep,
Uh-huh.
and not so wide,
Yeah,
and
that restrained it.
that
Uh-huh.
restrained it, so
Uh-huh.
it couldn't get out of there. But those things are fun.
That was always a job out in production, as I remember, to get that rear anchor set right.
Oh yeah, it had an arm
little
on it,
adjustment,
to
yeah.
adjust
Yeah.
it.
See, did you go through the series when we went from knuckle supports and knuckles to ball joints? Were you there in that time frame?
Yeah, I was in there too when the disc brakes came.
Disc brakes?
And the frames for a long time were riveted.
Mm-hmm.
And trying to be able to get into those rivets. Now, at the frame companies, they set those rivets cold. They had squeezers.
Oh, yeah, okay.
And, of course, out in the experimental, they had to heat them and they'd
drive 'em hot.
buck them and drive them hot.
Yeah.
But for a long time, those frames were riveted. And it was a pistol to figure out how you were going to get in to hold somebody.
Uh-huh.
So then they switched over to welding, and that was
Yeah.
so much better.
And where about, can you put that in time someplace about?
No,
Okay.
really.
All right. We had we also, Carl, had that initial F-85, which was a unitized body.
Yeah.
That
I
61.
was trying to think, we were talking about this skid and the railroad
Yeah,
tracks.
yeah.
It just runs in my mind. It doesn't seem possible that it was that we used rivets that long, but I guess maybe we did. It's possible that breaks in just about the time we were working on those skids.
Oh, okay.
I think that skid was welded on, though. I just cannot say when we switched over from rivets to welding.
That's all right.
But it certainly helped an awful lot on.
Did you work on any of the chassis stuff for the F-85, the 6123 F-85, that unitized body, or was that done outside of Oldsmobile?
Well, I remember doing some work on it, but I don't. I remember a stub frame.
Yeah, we had that little
stub
cross
frame.
member with the springs and all the stuff on it that we built.
Yeah, but there was a stub frame came down and fastened.
Yeah, and the engine sat on that thing.
I remember working on that. Because I remember attaching onto the frame that was under the other part of it.
Yeah.
I remember working on it.
Yeah. Okay. What do you think maybe over that period of time was maybe the most significant change that occurred?
Oh, change in what?
Pick the product. The product.
Change in the product?
Yeah.
Well, one big thing was a handy thing when we got off of building convertibles.
Okay.
We never made much money on them because the frames on those things were heavy. You know, you didn't want them shaking and doors flying open and all that. Normally, a frame is built with the idea that it has to be flexible.
Okay.
You know, if a thing's too rigid, it'll break itself.
Yeah.
But if you make it so it'll be a little flexible, why then it'll take a lot of guff. Well, a convertible, they're just it had to be the stiffener for the whole body and everything else because there was no top or anything.
Yeah. Well, you didn't. Once you went through the door, why is a big hole there?
Right. So, the stock sizes in a convertible way up, and of course, at that time you had X bars across.
Yeah.
And the drive shaft ran
through
down
the middle.
through the middle of it. But, well, that was probably a big thing when they stopped building convertibles.
Okay. Didn't hurt your feelings, huh?
Well, I don't know. Sales figures usually are what predicate that.
Yeah.
Well, there's a lot of things down the line. If you go way back, you'd say, well, rubber engine mounts were a big issue.
Okay.
And direction signals were a big thing. I don't know, most people probably didn't realize, but like your motor mounts, the diameter of rubber is different from the left side to the right.
Okay.
And the reason for that is that an engine, the old physics, for every action there's an equal and opposite reaction. So you made the motor mount, the rear motor mount on that side stiffer because of this tendency of the engine to want to rotate. So those were all little tricks of the trade that made good sense. Something else came to my mind when I was talking about those motor mounts. Oh, I'm trying to think. We had windshield washers and all that kind of thing in there ahead of that, so but I'd say some significant benefit was like direction signals and what was the other one I mentioned here?
How about changes in your bosses as time went forward? I'm sure you didn't have the same boss all that time.
No, George Jones was my boss for a long time.
Okay.
In the chassis group.
Yeah.
But then he went into body, and I don't remember who came after that.
Okay.
Normally, you don't have too much to, if you keep your nose clean and you do your work, you don't really have an awful lot of contact with your boss.
Okay.
The most is that,
Did they have get-togethers so that you would get information, or how did they manage the organization?
you had meetings occasionally.
Mm-hmm.
In fact, it's like the whole chassis group might have a meeting if it pertained to something
Mm-hmm.
with them. And why some of the meetings, I don't really recall what came out of them, other than if they wanted to say, well, everybody's going to do thus and so.
Mm-hmm.
And well, just such things as it got to the point where we couldn't leave at 12 o'clock and get anything to eat and get back by 1 because
Yeah.
all the State Department clogged
Sure.
up everything.
Yeah.
So there was a few complaints made about people coming in late, and told them exactly why. So fine, we'll leave at 11:30. Beat 'em.
Okay. Solve that problem.
Solve their problem.
Uh-huh.
So of course that never bothered me because I got tired of running out for something to eat. I used to take a
Yeah.
paper sack
Brown
with
bag
me.
it.
Yeah.
Yeah.
Had a little tuna or something. And,
Yeah. Yeah.
and a sandwich and this sort of thing, thermos bottle, and it was much easier to do it that way than to spend time running around.
Yeah.
Somebody had to drive down, find a place to park and all.
Sure. Yeah.
There was a cafeteria, of course, over engineering building, and right back
Right.
in there, upstairs,
Yep.
the second floor. There was
Back
a
in the engine
cafeteria.
plant. Mm-hmm.
And that, they had pretty good food for a while, and then all of a sudden the portions got smaller and the price went up and everything else. And
Like everything else.
bag.
Yeah, right.
But,
Um,
well, if the weather was bad, you had to
Oh, it was a long walk.
run across.
Yeah.
Well, we used to go across that parking lot,
Mhm,
come
over
out
the
the
track,
back of the
over the tracks.
engineering building, over the tracks.
Yeah, right, yeah. How about if you didn't see your boss too often, and how did you kind of know what you had to do, so to speak?
Well, of course, you had a boss here, and then you had like a sub-boss here.
All right.
And he'd pass the work to him, and then he'd pass the work to you.
Look over there.
Oh. She's talking about shipping cars. You know, they used to ship them in boxcars.
Yeah.
That was another thing I worked on. Oh, boy. There were 2 lengths of boxcars.
Yeah.
And you could only put certain combinations, you know, like a 98 here and an 88 here and a something here and a something here.
Yeah, so they fit in.
Yeah, you had four cars to a boxcar. And then you had all this mechanism to raise them up in the air and so forth. And that got to be a...
Was the mechanism part of the car, or was that
Part of the car.
Part of the car. Uh-huh.
Yeah, they could get them up and lock them up in there.
That was long before we had these tri-level cars that we use later.
Yeah,
here.
that came later.
Mhm.
Yeah, the
Mhm.
shipping them that way.
Mhm.
But that boxcar loading was...
So they must have had to kind of scoot the car and kind of
There
dolly
was
it around or something.
Separate, you know.
Yeah, because you can't hardly slide one in there sideways.
Yeah, because I'd lay it all out on paper, and I knew what room I had and,
Yeah.
and so on. And I just don't recall. I guess, as I say, there were 2 different lengths boxcars, and you had to shuffle the models according to what the boxcar would take. I remember every time there was a new model or something new on the thing, well, here you go again.
Mm-hmm.
But it's just like jacks. Every time they changed the front bumper, you didn't build a new jack, you built a new you know, little piece here that...
bracket.
Yeah, one time it had a hole, tit on it went up in a hole,
Yeah.
and the next time it had a contour and hooked over the back. And,
Uh-huh.
and yeah, I remember working on jacks. And,
Oh, my.
all, just about everything before you get done.
Uh-huh. What, was there always a press of time, Carl? Was that... did it ebb and flow during the year, or
well,
was that kind of a...
Here's what used to happen. Like if somebody come out and say, well, when do you think you can have this? If you were smart, you always said longer than what you figured you might get it at.
Mhm.
Because if it took less time, they were happy. If it took more time, they were unhappy.
Mm-hmm.
And no way, sometimes these things would take 2-3 months, and how are you going to say, I'll
Yeah.
have this thing solved? Ideas don't come like that.
No.
And so it's pretty hard. All that did was let you know that they were thinking about it.
Uh-huh. Uh-huh.
So, no, I can't say that they really pressured you that much.
Yeah.
I suppose if they thought you were goofing off, why they'd
Yeah.
let you know about
Yeah.
it. But
Yeah. People weren't leaning over your shoulder.
oh no,
Yeah.
no. That's a quick way to give the guy ulcers.
Mm-hmm.
No, they. Only thing is, I say, if the going got rough, everybody disappeared.
Mm-hmm.
You know, and
Interesting, isn't it?
and, that's all right too.
Yeah.
If you've got a constructive idea, fine. But
Yeah. Chief engineers, later on, did you deal with any of those at all? In later
not
years?
real close. What do
Okay.
you deal with them? You mean?
Well, I mean, to
discuss anything with them?
to
No.
understand them a little bit, how they operated, that sort of thing, how they managed the
No,
organization.
Really, you
Okay.
didn't get into that too much.
Mhm. Would any of those folks wander out into the
No, not
drafting
the
area?
chief engineer.
You wouldn't see
no.
those guys wandering
You'd see
out.
others
Mhm.
occasionally out,
Mhm.
if there was something specific. But you know, as I say, you had a boss here, and you
Yeah.
had a boss here, and
Yeah.
you had somebody here, and usually those things came down the
Yeah, the channel.
down the channels.
Mhm. Mhm.
We used to do a lot of work with the frame companies. It was A.O. Smith and Parrish Breast Steel.
Oh, yes.
Well, this is fine until they started changing the time around, and then pretty soon you didn't know when you could get a hold on anybody,
Mhm.
because their time was different than ours.
Oh, you mean
their
the
work hours.
uh-huh.
Yeah, so
yeah.
if you wanted to contact them by phone, you had to kind of run a test case and say, well, let's see, it's so-and-so here and it's so-and-so there. Well, they've just gone to lunch, we'll have to wait till later, and by then you've gone to lunch, and
Uh-huh.
you know, it really
Yeah.
fouled things up,
Yeah.
trying
Yeah.
to get
Yeah.
together.
Is there any section in all of that time that you were there that you thought was the most fun?
Probably the earlier years were, if you want to call it fun, were
Yeah.
well,
more
I
more
remember-
pleasurable,
yeah,
shall I say
yeah.
that? Maybe not fun.
Oh, I remember, like in the engine gang, if you drew a piston, if you were real familiar with it and you worked with your nose to the grindstone, you could finish one in a week,
Mm-hmm.
a detail of a piston.
Mm-hmm.
Because, Lord, there were like 3, 6.
This is a recording of Karl B. Hodges of North Fort Myers, Florida. The recording was made on January 21st, 1989 by Jim Walkinshaw of the Oldsmobile History Center. This is tape number 2 of 2 tapes.
Well, a lot of the work wasn't, an awful lot of the years was spent in improving something, and redesigning something.
Mm-hmm.
And I can remember working with modeling clay. At one time we were having trouble with the rear axle, and you probably don't remember, but we made the little pieces that were welded on to help strengthen that rear axle housing.
Okay.
And so you did a lot of things like that.
Mhm.
You modeled them out of clay, and like in a case of forgings or this or that,
Yeah.
if there was a weak spot, you might clay it in, and then you'd change the drawing
Mhm.
accordingly.
Mhm.
But not all of it was strictly start from scratch.
Yeah,
I mean, there was an
yeah.
awful lot of changes, and
Improve what you
Yeah.
have.
of course all changes were made was with the idea of was this, was that,
Mhm.
so that if something happened that they didn't want to do this, then they could back up.
Mhm.
But you didn't say, is this?
Mhm. Mhm.
Your changes were made with that in mind. And I remember notes on engineering drawings and that, if it were quite a complicated note, we'd compose it and then give it to somebody else that wasn't familiar with the job and say, well, what does this mean to you? You make any sense out of this? And if there were any criticisms, then you reworked it until you got it to where there was no chance of not knowing what the heck you were talking about. And
Sort of like asking your wife to review it to see if
yeah,
it made
but
sense.
you were very, very precise, you know, in how you stated things, because you didn't want any, well, like I say, was this, was that, and that gave them a chance to back up if something didn't work out.
Yeah. Now the engineer that you had chassis engineers that worked right along with you, I assume.
Yeah, but they were mostly on test work, and this sort of thing. Or if something went wrong, why they would. But then, well, it's just like this problem with the wheel coming off on the Tornado.
Yeah.
There was an engineer on that, and all he said to me was, he said, boy, I don't know where the heck you're going to do anything. It looks like the only place is in the hub.
Okay, so that was
that's it.
That's the direction you got.
That's the direction.
Yeah.
Well,
Yeah.
And I looked at it for I don't know how long, and it just looked at that brake and everything. There was just no way to get in there to do anything with it. So they don't stand over you. After you did something, then they might criticize it in some way or another. Or, you know, if
Critique
were, or they'd build it up and test it. So.
But they wouldn't hand you a drawing or something. This is what I think we ought to do.
In some cases they could. They might mark up a drawing and say, we want to do this.
All right.
And it was up to you to change the drawings.
So it ranged then the gamut of almost saying, here, Carl, see what you can do, to here's what we want. That range of things that you would get into.
It's according to, well, like I say, you had limitations, just like the pressure on the accelerator pedal had to be just so many pounds, or it made your foot tired, and that was no good. You did have limitations along the line on design as to what things could be. And, well, it's just like I was telling you, that you could change how fast it opened the carburetor.
Sure, just by where you put it on.
How you indexed the bell cranks, this sort of thing. Well, and you had to make sure that a linkage couldn't lock up on itself, and all this kind of thing.
Go over center or something.
Yeah, go over center, and then which would be akin maybe to a stuck throttle.
Right.
So you checked out all of those things, of course.
See, we moved away from the old linkage stuff in later years, you know, all the bell cranks and linkage and arms to cables and those kinds of things.
Up to a point, yeah, but of course you've got to have bell cranks in order to get this travel that you want. When you start pulling on a cable, something down here has to move. Has to do something. Cables are nice. You've had well, you know, there was a time when the speedometer cables worked off the front wheel.
Yeah.
They used to work off the transmission, and then they changed over to the front wheel, and then they changed back to transmission again.
Yeah, why did they do that?
I don't know why they changed back, because I think it was cheaper to, see, you had a little gear deal that had to go in the transmission, and it wouldn't be cheap by any means. Whereas the other way, you fed a cable down into the front wheel and brought it back up into the speedometer. And it's no different than a brake pipe or anything else. You know, it was flexible and it could move. Well, there's all kinds of things that you did. For instance, piping on an engine. You know that an engine rocks not about the center of the crank, but on a theoretical line down through. Now, they can establish that by hanging the thing from wires and doing this and doing that.
And running it.
But it does have a center of rotation. And the further away you get from this line, that engine can rock, 3/4 of an inch or more. So any pipe that fastens, like from the engine to the frame, some way you got to make it so that what you do is you put a bunch of loops in it, and it lets it work without
busting something,
or without loosening up the fittings and so forth. So there's all kinds of things that you did.
Okay.
Well, you tried a lot of different things. I remember in the engine group of trying to run all the fuel pipes down, like 3 pipes. I don't know if they all were all together.
Oh yeah, I remember that.
Instead of having them running all over.
Yeah.
What were those pipes? One was
Let's see, one was fuel return, and maybe the other one wouldn't have been the brake, would it? Have all three of those pipes
because they
together?
all seemed to started out near the carburetor for some reason. I don't know what it was.
Yeah.
Anyway, I remember trying to fit those
Yeah.
suckers down through there.
We used to have that funny little tin can in the trunk there for a period of time. Maybe that's when we did that.
I don't know, what was that?
That was an emission thing.
Oh,
Fuel can, what was that called? I can't even remember the name of it.
canister.
Was
There's
it-
one now up in the
Yeah,
front.
but this was a funny little tin can that sat in the trunk. It had 3 or 4 hoses hooked onto it. That darn thing, I remember making that over at Plant 3. That's the only reason I remember it, because it was over there.
Well, you know why they always put the spare tire under the right fender, don't you?
Right side, no.
To balance the weight of the driver.
Oh, okay.
No, most of the cars are driven with one person.
Sure,
And
generally.
that
yeah.
tire weighed a lot of
Yeah.
weight,
It was
so
40, 50 pounds.
so
there,
you put it on the right-hand
Mhm.
side, and that's why it was over there. It's
Mhm.
to help balance out the weight of the driver.
Seems like we used to screw around with springs too, didn't we?
Oh, sure. Oh, yes, yes. Fact is, before I left, they were running a program where they even considered what accessories were put on the car
Mm-hmm.
as to where they were and how much they weighed and everything,
Mhm.
so that you got a nice ride out of the car
Yeah.
as to know what all these weights were.
I remember out on the production side of the house, we used to go nuts with the variety of springs we had. You know, we'd have
Oh, yeah.
gone after gone of springs that were down on the line, and these were green and yellow and orange and purple and blue, and
Oh, yeah.
all those that we had to.
Well, I think probably what happened is that they looked at what was going to go on the car, and they told you that we want this spring here and that spring there and this
Yeah.
one here and that
Oh,
there.
yeah.
They told you what
Oh
springs
yeah,
to
oh
put
sure,
where.
oh yeah. They predicted what you were, scheduled for you, what you were
Of course,
supposed to use.
You had to be a little careful too, like on those front springs, you know, if you let her down and that spring could get out of that socket.
Yeah, that pocket.
Swing!
Yeah, right.
And
Yeah.
and especially if it was just the normal travel,
Uh-huh.
you sure didn't want one of those springs popping out.
No.
So they had a base to
Yeah.
contain them and everything.
Yeah.
But
Little tang in
there's
there.
another thing that you had to be careful of.
Uh-huh. We swung back and forth from coils to leafs to coils during the years, as I remember. In the 40s, we
Only
were
on the rear, I would say.
yeah, on the rear, not on the
Yeah,
front.
not on the
Yeah,
front.
well, we were the front long ago, but
Yeah.
not while you were there. Yeah.
Yeah,
Any particular reasoning in back of those kinds of switches that you can remember?
well, cost could be a factor. Maybe it was less costly to have a coil spring than it was to have these leaf springs.
But as I remember, we started out with leaves, and then went to coils, and then went to leaves, and then went back to coils.
Oh,
We swung back and forth, I'll bet, 2 or 3 times during that, what I'll call from the 30s to the 60s, when we got finally to all coils and just kind of stuck with it.
well, of course, the 30s, I don't know what they had there, but during war years, of course, there was no change much.
No, right,
And
Right.
so you're talking, as far as I'm concerned, from 42 on.
yeah. But that was all 4 coils, I think.
That was a few years too in
Yeah,
there.
yeah.
42 didn't start right out. When
Yeah.
did we start production? 44?
Yeah, after the war.
Yeah.
Yeah,
Something like 44.
yeah, late 44. Yeah.
Well, I don't know, unless you prod me with a question,
Okay.
how I can think of what else you might be interested in.
Yeah, that's excellent. Did a good job of kind of covering the kinds of
Well,
things that were
I
typical
told you,
of.
my experience would be more technical than
Oh,
it would be
Appreciate that.
knowing what building was where,
Oh,
what
no,
the number
yeah,
was
no,
on
no,
the
no,
building.
that's all right. That's not the kinds of experiences each person had were unique, and a person 50 years from now may wonder, well, what in the devil did some guy do in the product engineering department? And here would be the
Yeah.
typical kinds of things that individual would have worked on. So,
Well, of course, you have to recognize that we did everything graphically. This was before the days of computers.
okay.
Now, just before I left, they had started some design with computers.
Hmm.
One of the reasons I left was that I was faced pretty sure of having to go down to the proving grounds all week and drive back and forth.
Oh boy.
And I said, I don't want any part of that.
Yeah.
And I was going to retire in 2 years anyway. And I said, if something happens to me in the meantime, all my wife gets is what I've contributed plus
Yeah.
nominal bank interest.
Yeah.
And for 2 years, I should take a chance on that? I
Mhm.
don't see it.
Mm-hmm. Why were they thinking about sending you to the
Oh,
ground?
a lot, well, when they got into a lot of this designing, for instance, maybe Buick and Olds would use the same steering linkage. And
Coordinated design.
Yeah, coordinated design on
Uh-huh.
some things.
Yeah.
Well, then a lot of those fellows had to go down and work at the proving grounds.
Oh, I see.
All your steering linkage and that, I remember that fellow practically lived down there.
Mm-hmm.
And I was getting too old to think of driving down
Beating the
there
road.
and then having to live in a motel and eat out and everything.
Yeah.
That didn't interest me at all.
Yeah. When did you retire, Carl?
Oh boy, 74? Five 174.
5174. Okay.
That's a long time ago.
Yes, it is. Yes, it is.
Oh,
The-
everybody else is getting older, but me, that's all right.
Yeah, right. The computer was just starting to dawn then, huh?
Well, we had the big one downstairs.
Yeah.
And that did an awful lot. For instance, like in a front suspension, you could enter the 3 crucial location points. And then you could move something around in some other one, and you could shift it in half-inch increments.
Mm-hmm.
And it'd tell you exactly where that particular point was.
Where they were moving
Yeah,
to.
where we're moving to. And you
Uh-huh.
needed this for clearance checks and this kind of thing.
For the
Otherwise,
extremes of this expansion system
Right.
and so forth.
and you needed this for that. They had other programs too. We used to have to design all the springs, especially the compression and torsion springs in this. You know, you had certain constants, and you could
Mhm.
you
Mhm.
could put this in and then that in until you got a spring that would fit in where you
Yeah.
had it and would work and so on, according to travel and that. Well, later on, you could write out the information that you wanted and take it downstairs, and they put it through the computer, and they could vary certain constants and
Yeah.
but we used to have
Yeah.
to do that all by
All
hand.
by hand.
Yeah.
Yeah.
The fact is, I remember in the beginning, the only thing that we had for computations to help were these old type of things where you turned the crank and the thing had linked over and then you turned the crank
Oh
and it linked
no!
over.
Yeah.
Those,
Oh,
I don't know what
God.
they called those things.
Yeah, those were sort of
Not
early
Marchand,
Yeah, weren't they the Marchand calculators?
Yeah, I
Those
think
early mechanical calculators.
Oh, those
yeah.
physical things.
Yeah.
Especially if you had long divisions to do.
Yes, they would sit there and go clank and clank and
Yeah,
clank.
and you turn the crank,
Yeah,
turn the crank.
Yeah. Yeah.
So, the one thing we did have though, we had a dictionary that was about like so thick. And
Like an unabridged dictionary. Yeah.
Oh,
yeah.
a huge one on
Yeah,
a stand.
yeah.
That's a good thing. I never could spell too well. The days they were teaching spelling, they didn't do it the way
Yeah,
they should have.
yeah.
There were a lot of things they
Yeah.
did. And it's funny how many people can't spell, and I'm one of them.
Well, it was. I looked at that as being sort of a trait of a technical person for some reason. A lot of technical people
Oh,
can't
I've
spell
done
words.
an awful lot of reading,
Yeah.
all kinds and that, and I have I have a good understanding what the word is and everything,
Yeah.
but I'll be darned if I can
Yeah.
spell it.
Well, at least you know enough to go look it up.
That's right, of
That's
course.
half the fight.
You got to know somewhat how to spell it.
Yeah, where you can find it.
Yeah. How do you find xylophone?
Yeah, right, exactly right. Right.
So you have to have a
Yeah.
general idea
Yeah.
of
Oh, well, that's great, Carl. I think you did a good job of
well, I probably
Re-
left out a lot of things.
well,
but,
and it's hard to
jog my memory.
Yeah, until to do one of these and catch all the facts because it's inevitable.
Well, you're talking a period of 32 years.
That's
and
right.
And
And to
that
try-
was several years ago.
And to try and do that in an hour
Well, I
or two
was
is just
27 then, and I'm 73 now. That's
a couple of
quite
years
a while.
ago. Yeah. So that's just great, though. Well, we do appreciate it. So,
Well, I hope there's something you can use.
oh, there is.
But I think that some of these things, I know that there were a lot of, well, what do you call it when you make a small picture or something? You know, put
Where
on
you-
microfilms.
Yeah.
I'm sure that a lot of information is on microfilms.
Mm-hmm. We can just
Yeah,
find it.
Yeah.
Yeah.
But that jet rotor would be
Would be a good one to
would make
capture.
a nice picture too,
Yes.
because it's
Yeah.
you know, everybody says, what the heck is that?
Well, and we don't have a lot of data on the jet engine, in all honesty, so don't really have a lot of it.
It was real interesting to work on that.
Mm-hmm.
Laborious, but interesting.
Mm-hmm. Unique assignment.
Yeah, right.
Unique assignment.
I enjoyed that.
Well, I will shut this baby off.